I'm Jasmine Chu, and you're watching Phenomenal Physics, bringing you physics info live. This week, we are going to be talking about the Coriolis effect and the man that came up with it all. We are going to be explaining the physics principles behind the Coriolis effect, a little biography about Mr. Gustave Gaspard Coriolis and who he is, and a little myth-busting segment. Let's take it over to our history experts to learn all about who Mr. Coriolis is. Gustave Gaspard Coriolis was a French mathematician and engineer. He lived from 1792 to 1843. He lived until he was 51 years old. He died early due to his deteriorating health, which was an issue for him throughout his life. His father was named Jean-Baptiste Élisard Coriolis and his mother Marie-Sophie de Maillet. He was born during the year the French monarchy was abolished. He was brought up in Nancy, France, and attended school there. He sat the entrance exam for École Polytechnique in 1808, and he was placed second of all the students entering that year. On graduating, he entered l'École des Ponts et Chaussées in Paris. He worked for several years in Le Meurthe et Moselle district and the Vosges Mountains. Coriolis became the professor of mechanics at l'École Centrale des Arts et Manufactures in 1829. That same year, Coriolis published a textbook, Calcul de l'effet des machines, Calculation of the Effect of Machines, which presented mechanics in a way that could readily be applied by the industry. In this period, the correct expression for kinetic energy, half mv squared, and its relation to mechanical work became established. Coriolis' papers do not even deal with the atmosphere or even the rotation of the Earth, but with the transfer of energy in rotating systems like water wheels. Coriolis discussed the supplementary forces that are detected in a rotating frame of reference, and he divided these forces into two categories. The second category contained the force that would eventually bear his name. Coriolis did take on a position at l'École des Ponts et Chaussées in 1832. There he teamed up with Navier, teaching applied mechanics. Navier died in 1836, and Coriolis was appointed to his chair at l'École des Ponts et Chaussées. His poor health prevented him from furthering his teachings, and he died shortly after. His name is one of the 72 inscribed into the Eiffel Tower. What an accomplished man, wouldn't you say? Now let's take it over to our physics experts and learn all about what he actually discovered. Gustave is most well known for his work on supplementary forces that are detected in a rotating frame of reference, leading to the Coriolis effect. He also coined the term work for the transfer of energy by a force over a distance. The principle I am going to be talking about is the Coriolis effect and force, which was both named after him. The Coriolis force is an inertial force, also called a fictitious force that acts on objects that are in motion relative to a rotating frame of reference. In a reference frame with a clockwise rotation, the force acts to the left of the motion of the object. In one with anti-clockwise rotation, the force acts to the right. The effect of the Coriolis force is an apparent deflection of the path of an object that moves within a rotating coordinate system. The object does not actually deviate from its path, but it appears to do so because of the motion of the coordinate system. Now that we've learned about the physics principles, let's see how it actually works on the Earth. Let's take it over to our friends at PBS.
A storm's rotation is due to something called the Coriolis effect, which is a phenomenon that causes fluids like water and air to curve as they travel across or above Earth's surface. Here's the basic idea. Earth is constantly spinning around its axis from west to east. But because Earth is a sphere and wider in the middle, points on the equator are actually spinning faster around the axis than points near the poles. So imagine you were standing in Texas and had a magic paper airplane that could travel hundreds of miles. If you threw your airplane directly northward, you might think it would land straight north, maybe somewhere in Nebraska. But Texas is actually spinning around Earth's axis faster than Nebraska is, because it's closer to the equator. That means that the paper airplane is spinning faster as well, and when you throw it, that spinning momentum is conserved. So if you threw your paper airplane in a straight line toward the north, it would land somewhere to the right of Nebraska, maybe in Delaware. So from your point of view in Texas, the plane would have taken a curved path to the right. The opposite would happen in the southern hemisphere. An object traveling from the equator to the south would get deflected to the left. So what does this have to do with hurricane spinning? Well, at the center of every hurricane is an area of very low pressure. As a result, the high-pressure air surrounding the center, or eye, of a storm is constantly rushing toward the low-pressure void in the middle. But because of the Coriolis effect, the air rushing toward the center is deflected off course. In the northern hemisphere, the volumes of air on all sides of the eye keep getting tugged slightly to the right. The air keeps trying to make its way to the middle and keeps getting deflected, causing the entire system to spin in a counterclockwise direction. In the southern hemisphere, where the Coriolis effect pulls air to the left, the opposite happens. Storms spin around the eye in a clockwise manner.
Now that you've learned how the Coriolis effect works in terms of the tides in the oceans, you may want to see this on a smaller scale. For example, in your toilet bowl and the water swirling in different directions in different hemispheres. However, I'm here to bust this myth. Many people are quick to believe that the Coriolis effect can be shown through toilets in different hemispheres swirling in one direction in the northern hemisphere and the other direction in the southern hemisphere. I'm here at the equator, latitude 0, to prove to you that it's not true. Theoretically, it could be true if there was not friction or other forces acting on the water, but obviously this is not true because in the real world we live in, there's friction acting on the water and in the bowl. Many people believe this because they see videos of it happening, but actually the way the bowl is shaped and the power of the jets in the toilet actually propels the water to go in the direction they want it to. This video is an example of why people are quick to believe why this myth is true. In this example, water is placed in the southern hemisphere and swirls in a clockwise direction. However, it is simply due to the inside of the drain and the different shapes that propel the water in the different direction. In this second video, water is placed from the same bucket into the northern hemisphere and swirls in the opposite direction. Thus, by watching these two videos side by side, people believe that water swirls in different directions in different hemispheres. However, as I mentioned earlier, it's simply due to the inside of the drain. I hope you learned a bit about the Coriolis effect and now know that your toilet water does not swirl in different directions if you are in Australia or in Canada. That's all the time we have for Phenomenal Physics. I'm Jasmine signing off.